better in a culture that's getting worse. I don't know. It's hard. But I do know that in Christ that there is hope and that there is light and that darkness will not win. Permutations. Order is what? Permutations. Order is what? Important. Yeah, there you go. Anybody have any different ways of saying permutation? Don't say combination like a locker combination because that's an improper use, but use something else. Order, order rings, order rings. Anything else? Musicians, you should know this one. At least composers. No? Oh, I thought you would. Seating. Scale. Arrangements. Oh, scale. That's an interesting. Sorry. No. Arrangements. I was thinking like arrangements in music. But yeah, arrangements. Arrangements, orderings. You could even say like words, because then the arrangement of the letters matter. License plates. I mean, that just starts getting really specifics. Batting orders. Oh, hey, it's an ordering. That's cool. What's different in this example than the one that we talked about yesterday? Let me remind you of what we talked about yesterday. We had 6 letters, like letter tiles. We were thinking of how many different ways of arranging these letters without repeats because they didn't show an AA or a BB. And we use 6, 5, 4, 3, 2, 1, and the exclamation point is called what? Oh, it's right there, but everybody say it out loud.
Factorial.
Yeah, if you said factorial, thank you. You're contributing in class. Maybe you got that on your progress report comment. Those of you that are not contributing in class, maybe you're just quiet. It's okay, I still love you. Or maybe you're ignoring me, and then it's a little bit sad. Okay, so the exclamation point is factorial, and it means all of the numbers, 6, 5, 4, 3, 2, 1. But why does that not exactly work for this one? Why is the answer not 15 factorial? Brendan.
For the last slide where it says one combination, what does that mean? What are you talking about?
Oh, this was at the very end of class where I was introducing the idea of combination because we hadn't got to like the actual combination slide. Can anybody answer that question? I can, but can you? Noah, why does it say one combo?
Oh, I remember. Because because the order doesn't matter, so it's just you have one, like it's just one set of select things that you can create an order from.
Yeah, but Brendan, did that answer it for you?
I think so, yeah.
A quick illustration that I would say. Oh, what did I use? Oh, yeah, we did it, and it was gross and it was disgusting, but we were pretending that they were pizza toppings, right? We did like anchovies and bacon and Canadian bacon. Oh, they are different. And dill pickles, and then it started getting really gross, and then eggs, and then fudge. Anyway, don't think about it. Fish, that's not much worse. What's something that would go on a pizza with a feta? Oh, we could put feta. That wouldn't be near as bad.
Pineapple.
But no, that doesn't start with. You guys are so cute, but you're right. You can put that on a pizza. Okay, coming back. I know. But wait. So then, Brendan, the idea was you could put the anchovies and then the bacon and then the Canadian bacon, or you could put the Canadian bacon, then the anchovies and the bacon. That would be a different ordering of the toppings of you putting it on, but all of those 720 different ways of putting the toppings on the pizza is one combo, because it's all this. Yeah, got it. Cool. What's different in this one? Guys, why is the answer not 15 factorial and it's not 9 factorial? No.
Because you're choosing 9 from 15.
Exactly. Now, I know that you're thinking your calculator, and well, maybe. Joey would be thinking his calculator, and that cool little, what's that menu called in your calculator with these cool letters? Math probe. And then that probe probably stands for, never mind. That wasn't funny. Probably stands for what? Probably means for probability. Probability comes from probably. Anyway.
I don't know what we're saying.
It's okay. Where do we find it? Math and prob. You can say it's all your problems, but maybe all your problems are getting fixed. Probability, there's a NPR. So yeah, you could go ahead and say, I have 15 players and I'm only choosing 9 for a batting order. Is it 9 or is it 8? 9. Oh. And then, now we're not taking into account like coaches and their biases or like who are your star players. Like we're not taking into account some positions might be fixed. Like of course they're first, of course they're second, of course they're third. So we're not saying literally every coach has to think about 1,816,214,400 different permutations. Oh, how many times do we use the word combination and it doesn't really mean the same thing? Anyway, coming back. We're not saying every coach faces that, but that's how many different orderings there could be. But question, where does that number come from? What I was saying is, why is it not... Where's the factorial in your calculator? I mean, I could do 15, 14, 13. Where's factorial? What do you think? Maybe where all the other probability stuff is? Oh, there it is. Although, are there really cool hidden menus somewhere? Number 9. Yay. Okay, cool. Where did I go? I went alpha, I went window, and I went not absolute value or the other weird. Ooh, those are calculus, but I went to number 9. So how does it compare? Well, let's see. 15 factorial would have been lots bigger. 9 factorial would have been smaller. Huh, where's this number coming from? It's not 15 factorial, it's not 9 factorial.
Because you're trying to figure out of knowledge, or like whatever.
What was that principle that we talked about last time that says if we're doing multiple things, like choosing multiple digits or multiple characters on a license plate, or we can do what in between the number of options on each? Multiply. What was that principle called?
Fundamental.
Fundamental what though? Careful, every branch of math has a fundamental. Fundamental what? Counting, because we're trying to count up how many ways. Principle? Principle, oh yeah, how to spell. Anyway, coming back. So, what numbers go in here for who's batting first, all the way to who's batting ninth? How many options do I have for who bats first?
1.
Oh, 15.
15. I have 15 different players to choose from, but if one player is chosen here, I only have how many to choose here? So why wasn't it 15 factorial? Because, what happens? I'm not ordering all of them. Yeah, I stop. Mathematically, how do we talk about stopping, though? I know there's this cool button. I know it's in your calculator, etc., etc., etc. But factorials say, hey, it's everything down to 1. But wait, I don't want 6 or 5 or 3, 4 or 3 or 2 or 1. Oh, hey, I don't want 6 factorial. And how do I undo multiplication? So this is 15 down to 1, this is 6 down to 1, and so then that's going to take off the 6 and the 5 and the 4 and the 3 and the 2 and the 1, so I'll have the 15 factorial just stopping there. Do you see how the formula works? It's 15 factorial over 15 take away 9 factorial. Oh, that's snazzy. So if it was on like a non-calculator part of the test, you could do it? Or you could at least write it? Okay, I'm not saying do that in your head. I'm not saying that, but you could write it. 15 factorial over 6 factorial. That's why you're still writing this down, even though, Joey, I know there's a really cool button in your calculator. Let me go grab a picture of that really cool button in the calculator that gets me the right answer, not the wrong answers, and let's go on to the next page. But does that kind of make sense as to what the button's doing? And if you don't believe me, I'll go ahead and do not the 15, not the 9, but the 15 factorial. Ooh, here's the nice little shortcut. Divided by the 6, the 5, the 4, the 3, the 2, and the 1. AKA 720, but we'll just do it that way. Dun, 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 dun. Same number. Cool. Let's keep going. So what's so different about the repeated objects? I know. Some of you watched it. You know what it is. I just thought about somebody, how they would take that. Like if you weren't in a math class that did WebAssign, and I said watched it, anyway, I got the creepy clown in my head. Never mind. You watched the whatever tutorials on WebAssign. I don't know how to say bless you for a yawn, but I'm saying it. Good morning. Here we go. I know it's warm. I'll get air going. The question is, from what we've just done, what is so different from this? Now, if they say permutations of the letters, question, that's awkward. Question, how many letters do you think they're meaning? How many letters should you assume?
2.
How many letters should you assume that you're arranging if they just say the letters?
All of them?
8.
Assume
26.
all of them.
Oh, right.
No. All of the ones given.
Oh.
So I guess they said of the letters of the alphabet, it'd be 26. Yeah. Good to remember that. But for these directions, right? They give you B, 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 T, 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 T. T, T. I didn't remember how many I'd done. But they give you these letters. So if they don't tell you how many, then you're assuming it's like the letter tiles, and you're just rearranging them, and it's like, yay! So why wouldn't it be 1, 2, 3, 4, 5, 6? What is that? 8? Why wouldn't it just be 8 factorial? Because you're using them all. I don't have to do the whole like dividing thing. Just thinking about these three, wouldn't the permutation say there are 6 different ways of ordering the B's? If I just look at the B's, wouldn't permutation say there's 3, 2, 1 different ways of ordering the B's? But aren't they all just little font color black B's? So if I do the first B, second B, third B, or the second B, first B, third B, or the third B, first B, second B, question, are these 6 different orderings making a distinguishable permutation? No. Well, how do I undo multiplication? You divide and you say, well, not those ones. I'm not subtracting. I can't subtract. That's not a way to undo multiplication. Remember, in this 8 factorial are permutations that don't make a distinguishable difference. Reordering the B's doesn't make a difference. What else won't make a difference? Any reorderings of the T's? Well, how many permutations are just reorderings of the T's? 5 factorial, right? 5, 4, 3, 2, 1. If you just have all the like T's and you're like, well, the permutations would say these are different, but they're not. So what am I saying up here? What is N1? What is N2? What is N3? Where N, what would I say? N sub K? Yeah. Are the number of times, how are you putting it, Ryan? I like that.
N1 is 3, 2 is 5, 2 is 5.
Yeah. And where did those come from? It's the number of times. Yeah, repeated. Is that cool? Number of times repeated objects occur. You know what? I can make this a little bit more mathematical. Hold on. There we go. I can put the K right there. So K objects. Guys, how many objects were repeated in this list? Oh, sorry, that was meant to be a really easy question. How many types of letters are repeated in the number 1? 2. A B is repeated and a T is repeated. Is that okay?
Yes.
So how many N's am I going to need to put down there? 2, because I have 2 objects that are repeating. Repetition of 2 objects is occurring. Are occurring? No, is occurring. So I would just need the 2 different objects that are being repeated and how many times each of them are being repeated. So 3 for that one, 5 for that one. Awesome. So what would you do for this one? I'm arranging all the letters. So 1, 2, 3, 4, 5, 6, 7. Do I have any repeats? The worst thing ever in Wordle when you have repeated letters. Who's being repeated? Oh, so all I need to divide by, he's the only repeated one, so I'm only going to have to divide by 1, because only one object is being repeated. So, how many times?
2 factorial.
Vault it! Dun 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 dun. Is there a button in your calculator for that?
No.
Now what if I was to ask a different type of direction, or add to it, and then say distinguishable I'll just put, careful, it can be distributed, that could be a lot of different things. It's distinguishable, permutations, perms. But let's not do any permutation of all the letters. Let's do 3-letter permutations. What would change? What if I wasn't using all 8? What if I wasn't using all 7? What if we weren't doing all the letters? What if I was saying 3 letters? Am I using all of them? or only some of them. If I'm using only some of them, I have to think batting order. I mean, I think I have to think NPR. So what could I do? I would have that guy. I would have this guy. I would have that guy. But question, what else would I need? If it was 3-letter permutations, I'm not using all the letters.
1 over 3. N minus 1.
Yeah. Wouldn't you just have 8 times 7 times 6 on the numerator? So I would need to do divide by 5 factorial, because in this case, I would have my 8, my 7, my 6. And then those would be my 3 letters, and I wouldn't have any more. So to get my 8, my 7, my 6, I do 8 factorial divided by 5 factorial, so the 5, 4, 3, 2, 1 is gone. Another way of looking at this, though, where you could use your calculator for not all of it, but at least some of it, is that you could just say 8p3 all over 3 factorial, 5 factorial. Just showing you that we can do this whole, like, not all of them, we can do some of them, but you would have to use your NPR combined with that whole, like, division by the repeats. Let's not worry about 45. It'd be the exact same thing in the sense that you would just be doing 7p3 divided by 2 factorial. I just wanted to show you one. What if you weren't doing all the letters? What if you were only doing some of the letters to join both this idea, batting orders, and the NPR formula with this idea of the repeats? That is permutation. Everybody say done. Let's go on to the other guy then. Who's the other guy? Everybody say combination. Ah, party poopers. It's okay, I'll say combination. Combination. Like a combo pizza, no longer available at Costco. Everybody say
Wait, really? You can't have pizza at Costco?
they don't have combo pizza in the front anymore. At least a couple that I've been in. So maybe not an off for you. Once again, I'm curious. Whoever goes to Costco next, actually it's probably me. Not in the back either, in the frozen section. It's gone. Another sign of the state of our culture. So well, think about it this way. If you were being efficient with your time and mental, physical resources, you wouldn't want to not write it down at all, because then you couldn't refer to it later, studying for a test, doing test review, etc. But couldn't you think mathematically and say, how can I use shortcut notation to get all the key information down? Which is why, once again, you are privileged. Kids in the past that didn't have WebAssign. Kids in the past before COVID had to write down for every single homework assignment, not just the answer, not just the work, but also the directions and the givens. But as they did that, they learned how to write the key information down quickly. And what were their brains doing as they were trying to save themselves time? Synthesizing, summarizing the information, which any teacher, any brain researcher would be the first step of understanding the information. Reading comprehension? SAT? AP exams? PSAT? Anyway, alright, Oak College is forming a 6-member research committee. Has anybody pulled out the key information? Are we not there yet? Are we still doing it? Pull out the key information, write it down. Will you have it all? Having a paragraph of blah. Let's be honest, how many of you actually understand the blah, and how many of you are just waiting for me to go over it and be like, okay, cool, moving on. I know! So stop and realize reading and synthesizing is something that you won't be able to escape in almost any future endeavors. So let's practice that in our math class. Let's practice it in a way that math is trying to not just be more efficient, but that is one thing that it pursues. Huh? What were we thinking?
No, I just remember like doing like NPR before. Did we do it before?
We did it last.
Yes, we did it in algebra too.
2 at the very end.
Oh.
But just now, he's like, oh, yeah, you're right though. Right. At the very end. We didn't do it very much, but we did it some. I think it was the last thing. Was it the last thing?
It was like the last chapter.
Yeah. And we like did pieces of it.
Wait, where's Mr. U work now?
I saw Mr. U at the church.
Did you? You can see him on Sundays at Restored Church LA. You can see him, he's doing like some private tutoring. He's going to grad school, or he's doing his prereqs for some grad school stuff. And I don't know, he's really active at our church. I'm not sure where else he is. Who else? Who are we wondering? Mr. Chang, he's at Oak. Mr. Grapp is in Northern California, where I don't know where he's teaching though, but where his wife has a job. Yeah, she was an animal trainer worker. Got a job up there.
Oh yeah, Mr. Clark.
I love Mr. Graham.
Oh yeah. What about Mr. Clark?
Who else?
Johnny's asking
Mr.
Mr. Wing.
Oh.
I don't know. Good question. I was looking up something really quick. I should know off the top of my head, but maybe I don't.
He didn't even have realize.
Yeah.
Oh, please.
Oh. Where's Mr. Fix it.
You got a little 26.
I don't like
And he didn't even have Are you serious?
I'm double checking real fast that I'm not being false. Yeah, sorry, so many people are pregnant at our church that I lose track. Mr. Yu is also preparing to be a dad. It's getting really close for him now. Here we go. A local college is forming a 6-member research committee. I gave you more than enough time to write down the key information. So question, what's the key information? What am I trying to make? But on that committee, what do I need to know?
1 admin, 3 faculty, and 2 students.
1 admin, 3 faculty, and how many students? Oh, duh, that's 4, so it has to be 2, right? Or else you're picking like someone random to be on your committee, which you could. They're called stakeholders. They could be like parents or business leaders, or you don't care. There are 7 admin, 12 faculty, and 20 students in contention for the committee. How many 6-member committees are possible? So wait, do you have to pick an admin? Yes or no? You don't?
Yes. Well, 1 admin.
I mean, it has to have an admin, right? Okay, so I have to fill the admin role. What else do I have to fill?
3 students. 3 faculty members.
I have to pick some admin. I have to pick some faculty. And I have to pick some students. Anybody know why I'm writing this with blanks? Because you have to do this and this and this. Are we seeing the connection between multiplication and the word? No, careful. Because we talked about the blanks and the multiplication long before combination. What's the word that I keep saying where I'm putting the multiplication? We have to pick admin. And. Oh. I have to pick admin, and I have to pick faculty, and I have to pick students. I had to pick a letter to go in the first spot, and the second spot, and the third spot. I had to pick someone to go first, and second, and third, and fourth, right? What's another word that I could be using, but it wouldn't mean the same thing? Instead of and, it could be or. But would that make sense, picking your first or second? Or, that doesn't work, right? Picking an admin or a faculty or students, that'd be a totally different meaning. The and is leading to multiplication, and P.S. it's actually coming in section 9.7, the connection of and and multiplication. For right now, let's go ahead and finish this up. Question, how many admin could I choose from?
7.
And I'm just picking 1 admin, right? So why doesn't it work for me to put a 12 here? I'm not just choosing one of the 12. One blank O. So what could I do? Well, okay, some of you are thinking, well, wait a minute, couldn't you call like that faculty 1? And then you could call this, so there's 12 options for the first faculty, and then I could have the second faculty, and then the third faculty, right? And then we move to students. So why isn't it 12 and 11 and then 10? That's not the answer. Why is that wrong? What would that be? A combination or a permutation if I was doing 12, 11, 10? That would be orderings. 12, 11, 10, that would be permutations.
12, 11.
But question, do I have like a chair that says faculty 1 and then another chair that says faculty 2, and they better sit in the right chairs, and they better have their little like number 1 tag and number 2 tag, and it's important I know you're number 1, it's important I know you're number 2. No, I just need them in the room. Is it a permutation or a combination that I'm doing?
Combination.
It's a combination. So instead of doing, wait, Joey, you love your calculator. What could you type in to solve for 12, 11, 10? What button means the same thing as that? No, 12, 11, 10, isn't that like batting orders?
Also 12P.
Yeah. This is the same thing as 15P. I didn't write it. Oh, it's right there. It's right there. 15P9. Right?
That's with order.
15P9 is the orderings. I could have done an NPR to be 12, 11, 10, but we said that wasn't the right answer, and I'm not doing permutation. So instead of doing that, what am I going to just fill into that nice little faculty blank? 12CR, and specifically 12C3. Now, what does that actually mean? And then we'll go back to why we didn't do it with the admin. But what this actually means is that I have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, except I'm only choosing 3 of them, so I'm taking away that 12, 11, 10. I'm taking away the 9 factorial. But once I have chosen my 3 people, the 3, the 2, and the 1 of the different ways they could be seated or numbered, or like, oh, you have your first faculty, second faculty, third faculty, second faculty, first faculty. I need to divide by that because it doesn't matter. I just need them in the room. So I'm saying once I have my 3, I need to divide by the 3, 2, 1. That's why it doesn't just have the n minus r. It also says, well, once you have your r, those orderings don't matter. Take them away. Those orderings don't matter. Take them away. What do you guys think that we should fill in for students now? How many students total? 20. And how many do I need on my committee? 2. Which would be the same thing as, just in case you're wondering how combinations work, I'm kind of showing you the formula at the same time. It is the NPR. It is that like, hey, 20 factorial, but it's only 2019, so take away the 18 factorial. Oh, but by the way, once you have the 2, I don't care if it's first, second, or second, first. I just need them in the room, so take away the orderings of the 2. So then the question is, why didn't I make a big deal about this one being a combination? Because I would have needed to do my, how many do I have? 7 factorial? 7 factorial. However, I'm dividing by the ordering not mattering. 7 minus 1. I'd be taking away 6 factorial, right? Because it's just 7. And then I only have 1, and the ordering of 1 doesn't, it's just 7. Because it was 1 spot. Things started getting tricky when it was 3 spots or 2 spots, because the permutations say, hey, orderings matter. But when it's just 1 spot, it's like, well, I don't know, 7 people available, I need 1 of them. So could I have said 7CR? Of course I could have. If you wanted to, this is the same thing as 7C1. Anytime you have a 7C1 or a 7C7, there's only one way, one combination to do that. I said that wrong. 7C1, there are 7 ways to do that, or 7C7, there's only one way to do that. Okay. And then you guys would throw it in your calculator, and we already talked about the math probability, and if the math probability menu has an NPR, not like the radio, but like the permutation, it also has an NCR, which I don't know anything that has NCR. Nope, I got nothing. Okay. And And that's section 9.6. So those of you guys that kept on going in section 9.6, my question to you now is, for the rest of WebAssign, do we have any questions?
I have a question on like a calculator question.
Oh, I'll come back and see. Then, if some of you guys have calculator questions, let me go ahead and pause the recording. People that are watching this, you can either just keep watching the recording. We're going to go straight into 9.7, so you take all the notes for today, and then you can do WebAssign at the end, or people in class be able to finish up whatever problem you're on. But just talk about number 7 real fast, and not just the watch it why, but the actual why. If you were to answer a 10 question, true or false exam, you can think of it a couple different ways, but one way is literally thinking of 1 and 2 and all the way down to number 10. How many options, not what the answers could be, but I mean kind of. How many answer choices do you have for number 1?
2.
Yeah, you could have answered true or false, and then for number 2 you could have answered true or false, and then for all the other ones you could have answered true or false, all the way down to number 10. So then if I end up thinking that fundamental counting principle, all I have to think about is multiplying all of those possible options, because you could have had a true or a false, and then after that you could have had a true or a false. And then it's just going to keep on branching out from there. If I wanted to think about all the different ways you could possibly like answer the different questions on the test, I would just have like a whole tree diagram. But to save my time and effort, they're not asking for all the different arrangements, they're just asking for how many. So it'd be 2 to the power of 10. Dun, 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 dun. Which ends up being 2 times 2 times 2, that's 8. 8 squared is 64, that's 6 2s. 64 times 8 would be 2 and 3, 5, 12. And 512 times 2 would be 1024. Is that right?
Yeah.
Ready, set, and woohoo! There it is, go. Alright, cool kids, that is section 9.6. Let's go ahead and everybody, WebAssign closed. WebAssign done. Notes back out, 9.7 open. For those of you guys that, for one reason or another, are like, okay, I like to think carefully through my homework and or the week has been crazy and you just finished 9.6. I need more time because I don't just watch its. Just kidding, that's not totally bad. If you watch its, but who's like, can you just have it extended to next class? Because that'd be cool. Anybody need 9.6 extended past 11:59, you want it extended to next class? No?
No.
David's a yes. Anybody else a yes? Hey, stop. They're allowed to advocate.
What did he say?
Bro, he was literally absent.
He might actually like think about his homework. Okay, I'm gonna go ahead and, guys, it wasn't supposed to be public shaming. What's wrong with you? Thank you, David, for your boldness. It saves me time and you time and needing to extension requests. Anybody else? After that, no one's going to. Come on, who else needs it? Give me a head nod. Who else needs it? Give me a quick little subtle nod. 159, you're good?
No, I think I can finish it. I was just gonna ask for 7.
Is there like not a lot of
It's
work
10
to
times
show
more.
for this section?
I was wondering why you did like 2 to the power of 10.
Because, did you see that tree I was starting to make?
Yeah.
It's gonna grow exponentially. You were thinking, what were you thinking?
2 problems.
Think you were thinking all truths? Or all falses? No, that.
There's 2 options for each question. There's some questions.
Yeah, I see how you did. But you didn't think fundamental counting principle. As everybody else hopefully has their notes open and are hopefully taking 9.7 notes and hopefully not just wasting this time that I'm giving you. Thank you, Joey.
Definitely not.
What's behind the frozen snowflake? A P for probability and an E for.
Outcome.
Nope.
Oh.
I thought they were equally.
It was in the vocab of the video that we watched. Student council, you have to work extra hard when there's a what coming?
Event.
Ah, it's the probability of an event. Thanks for filling in that blank. Ryan, the reason that yours doesn't work is because I literally need to think of, like, for number 1, answering true or false. For number 2 is going to double. Those 2 are going to be multiplied by 2. True, false, true, false. So, number 1 has 2 options. Number 2 has 2 options, but in conjunction with these 2, there are now 4 options. The next one for number 3 is going to make 8, the next one 16, the next one 32. This is that multiplication principle of I need to keep on doubling every time I add another question. Because then this would have, sorry. So that's just question 1, question 2, question 3. How many different ways can someone not answer question 3 separately, but answer 1 through 3? That's going to be 8. So if it was a 2-question quiz, you'd have 4 different ways. If it was a 3-question quiz, there'd be 8 different ways because you could count them up.
Oh, it's asking like how many ways of different combinations. Oh.
Permutation.
Permutation.
But yeah, I know. Does that make sense?
Yes. Okay.
And then we just have to keep on. Okay. Some of this vocab we were talking about in our, I guess the guys talked to the guys. It was, I think, one teacher who was making those videos. Not that it was the most exciting thing ever, but he did give a quick introduction. I tried to choose one that was shortest. Talked about outcomes, talked about sample space, whether the outcomes are equally likely. A sample space is a collection, a total collection. Yeah, I'll do a collection of total outcomes. Specifically, you can think of a number. Like for our purposes, we're thinking of a sample space as far as how big it is or how many would be in the total number of outcomes. Outcomes, I can have favorable or unfavorable, but what could actually happen? Let's see. In my head, I'm like, an outcome is an outcome. An outcome is what could happen.
What produces the cause?
Yeah.
Solution produces.
So it's not always a solution, you know what I mean? What could occur? Can I just put it that way? There you go. Here, I'm using that wording. Which could be favorable or unfavorable. As in meeting a condition or not meeting the condition. There you go. I don't mean favorable, unfavorable as to which one you like better. I mean favorable or unfavorable as far as meeting some condition that's been given to you versus like even or odd. It says even, okay, that would be favorable, odd would be unfavorable. If it says odd, it would be switched. If it wants you to pick a heart out of a deck, okay, then hearts are favorable and any other suit is unfavorable. Meeting condition, some condition. Meeting some criteria, meeting some condition. I know, sorry, got messy. Favorable is you're actually meeting or satisfying. You could also put satisfying a condition. Unfavorable is you're not. And then you add the favorable plus unfavorable and you get the total. So total outcomes can also be seen as the favorable plus the unfavorable. But these are still counting. Outcomes are counting. Sample space is counting. This is still like a how many. These are not chances, these are how many. So I'm going to put just quickly off to the side. This is still 9/6 for a second. Counting. Probability says, I take these totals and I divide them. In the sense of I have the number of, N is for number, N is thinking like I've counted up how many ways an event can occur. So these would be like the favorable outcomes. How many favorable out of the sample space, aka the total. And the sample space should always be bigger than or equal to the favorable. Does that make sense?
Yes.
Sample space is total, favorable, and unfavorable. If there's no unfavorable, that could possibly happen. Like if I say pick a number 1 to 100, and what are the, I shouldn't say what are the odds yet. How many ways can you pick a positive number? You're like, it's all of them. It's So what are the chances of you picking a positive number? 100%, because it's all 100 numbers divided by all 100 numbers, because they're all positive. So the favorable could be equal to the sample space. I said sample spaces. Sorry, it should be singular for whatever you're talking about. There you go. Take that ratio, it's a decimal, and any decimal, which is 0 point something something something, can be changed over to a percent, right? And how do we change any decimal to a percent? Multiply by 100, aka move the decimal places 2 places to the right. Make it smaller to the left, that's negative notation. We're not going into scientific notation today. You guys ready? Couple more seconds. Are you guys so thankful, those of you going to Disneyland tomorrow, that you're not missing math tomorrow?
Yes.
Guess what all the AP kids are missing? Math.
When does that mean
Right
you get a
before their
Y for
AP
me?
exam. No, the ones that are here we're still going to practice. But the ones that are not have to. But they're just doing
Oh no. Almost push up, push up, still miss.
You know what? It's because it's
Yeah. Even if you shoot all your shots, you still miss somehow.
I know, right?
It doesn't make sense because if you
But I'll miss them all if I don't take them.
if you never shoot, you either you won't miss. You either you don't take them, you won't miss.
But then you make no point.
So you can be really good at it, but you still won't miss.
Yeah, you won't.
I'd rather if I know I have a better chance of missing, I'm really.
No, yeah, that's one day.
I did last time. Whatever, how many years ago that was. But that was also, I think, was that Richmond's last year? I think it was. So he was like, Tuli, Michelle, let's go. Sponsors aren't invited to this one, but I am going to grad night, so I guess it's okay. Although I probably would have rather gone tomorrow, but it's okay. Grad night's good too, as long as they make life choices. Okay, I'll get a Dole Whip, it's okay. It's all about the Dole Whip. And the skewers. Those are good too. Right next to Indiana Jones. Right?
Yeah.
That's my grad night meal. And then they started like not having us go to Disneyland, and I was like, ugh. So then bread bowl, which was good. Okay, here we go. Sorry. You guys are done, right? That random tangent, that's mathematical, it's calculus. Johnny appreciates it, no one else does. Here we go. I said after that random tangent, and then I was thinking back to good times. Hey, can you fill in the vocab words from the videos? Because they totally said how to fill in these blanks in the videos. I keep on saying they, I mean he. It was a singular person. Anyway, if the probability of an event is 0, then event E... Or if the probability of an event is 1, then event E...
2.
You want me to help? 2.
Yes.
I don't know what you're talking about. Ooh, nice! Keep going. Can you fill it in? Joy notes. You can say cannot or does not. Cannot or does not. Cannot probably is better.
Does it mean that E is a possible event?
No.
Uh,
But more than that.
constant.
Probable.
More than probable.
If P
Probable would be over
always
50%.
favorable.
Absolute. Event E can occur.
Absolute. A better way of saying absolute in the video, he said it too. A certain, we usually use certain, but absolutely. It's an absolute event. It's a certain event.
Is the next blank can?
Yes. No. More stronger. Will.
Yes, but
I was gonna put must, to be honest, but will occur, must occur. The probability that the sun will shine today. Well, it's currently shining, so 100%. The probability is 1. Remember, 1 is 100%. We talked about this the other day. So remember real quick, the probability of an event is going to be in between 1 and 0, and it might be impossible and it might be certain, which is why we throw on those little or equal to's.
What about a solar eclipse?
What if in the middle of the sentence?
Well, somewhere
there's
around
a
the world, the
5
science
hours
station-
Oh,
somewhere.
isn't it?
That is true.
Like an
Norway,
Perspective.
Norway?
Northern.
Norway is northern. Yeah, I mean, I bet Norway has northern lights. If you toss 2 coins, what is the probability that both land heads up? How are we gonna do that, guys?
1 over 2 times 1 over 2. 1 4. See,
Dang, I like did that without.
If you have a room full of
But like, I didn't know
40
if it was
people,
right or not. I
just
just
tell you
said
the same birthday as
25%.
another person.
You toss 2 coins, what is the probability that they land heads up? What'd you guys say?
1 over 4.
1 over 4, how come?
1 over 2 times 1 over 2.
But how'd you find it?
1
I
over
don't
2
know.
times 1
My
over 2.
brain said 25%.
Because it could be a heads over a tails and a heads over a tails. Look at you using the fundamental counting principle and the and. Or you could say what?
25%.
Or you could say 2 times 2 as in the different like total outcomes is I don't care, 2 ways of landing, 2 ways of landing, and then what could be on top? 1 and 1. Right? Or you could literally list them all out and you could say, okay, I could have, let's see, heads, I could have heads, tails, I could have tails, I could have tails, heads. Are those all the sample space?
Oh, I used to do
Yes.
it like that.
And then how many is heads?
1.
1 out of 4. And that's great if there's only like 4 chances. What if, or 4 possible outcomes, the sample space is only 4, but what if the sample space is like 1024? I don't want to list
That's a
those.
lot of tea.
Don't worry, letter B isn't quite as nice in the sense of it's not just 2 different options and it's not just 4 different things in the sample space. The letter B isn't quite as big as like in the thousands. It's just talking about a standard deck of what?
Cards.
So let's go through all the details of a standard deck of playing cards because some of you might not use them, play with them, know the numbers in them. This might help you in your future anyway. I don't know. Like on trips because playing cards is fun. How many cards are in a standard deck excluding jokers? We can think 2 jokers if you want, but then usually those are taken out for most games, so we said 52 standard cards. If you're thinking standard deck, you're only playing with the 52. In the 52, you have how many different suits?
4.
4 different suits. What are those 4 different suits? I have 13 hearts. I have 13. I have 13.
Gold and silver. Cards, clubs, and spades.
How many clubs? Oh no!
Broccoli.
Broccoli?
That's closer. And then 13 what?
Spades.
Is it 3 clover or 4 clover?
It's a 3.
It's a 3, right? And 13. No, I already have hearts.
Because
Spades.
clusters are
Spades.
What do those look like?
It's like a heart with
It's
the
like this, and then it goes.
It's the
And then it's like a rose petal.
Like make it pointy. It's an upside down heart.
It's like an upside down
And
heart.
then go inward.
It's at the bottom.
And
It's
like,
like an upside down
halfway.
heart.
Oh no!
Opposite way.
Oh yeah, that works.
It's like an upside down heart with a stem.
It's an upside down heart with a stem.
Just draw like half a line.
Upside down heart. It's like an apple.
Christmas tree. Okay, anyway, we're done.
This?
Why can't I think of this? I play cards all the
It's
time.
an upside down heart with a stem.
It's like
Um,
the Moscow, click the Moscow thing.
The must.
Yeah, it looks like Moscow, but 2D.
okay.
The Cathedral of Moscow, but 2D.
Why are you so good?
There we go.
Easy.
Okay. There we go. This one's better. Ew! It's gonna be pixelated. Oh no, it's not bad. It's not bad.
From last year.
Hmm?
We did this.
Remember Mr. David's class where we...
Wow, my.
Yes.
So guys, what's going on? Well, hold on. Wait. In each of the different perpetrators. Looks better if it's shaded. And then as we're doing this, guys, what's the probability they're asking for? What else do I have to think about in each of the different suits?
One of each suit.
Oh, each of these have a collection of 1 ace.
One, two, 1, 2, 3, 4, 5, 6.
Okay, so how many number cards?
2. 9.
Because it'd be 2 through 9, right? No, 2 through 10?
2 through 10.
2 through 10.
So then that'd be 9. So 9 numbered cards. No, there's not an 11 because what's 11?
11.
Joker.
No, so what if there was?
Then we have 1. Not Joker! Wrong word! Jack. We have 1. Queen. And we have 1. Okay, so what are they asking for about the probability? Question, what is the sample space as far as the total number of possible outcomes if you're picking how many cards? You're picking how many cards? So there are 52 different possible options if we're assuming a standard deck. The jokers aren't in there. But then we're trying to get how many aces, right? How many aces are there? 4. No, there's 1 per suit, which means?
4.
Nice. So that would be a 1 out of 13 chance, or, and you guys can fill it in as far as percentage. Okay, yay! But that's basic.
We're so smart.
We're gonna end here today. We're gonna end here today. We're gonna end here today. Today, it was actually something I said about earlier in section 9.6, so I wanted to get here and we got here good, and we'll finish the rest of it on Monday. Hey, check it out. Remember, spiritual emphasis week, chapel, 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 AB. Here we go. And one way of showing and is a way that you guys have already used even just a second ago in the sense of 1/2 and 1/2 for the first roll and the second roll. The fundamental counting principle says one way of thinking about and is just using a multiplication of separate events, like event 1 and event 2. The same way that we could do that with numberings or countings, we can also do that with probabilities. And if we're talking about some sort of like probability of A and B, occurring, that's snazzy notation, means the same thing as and, probability of A and B occurring. One way of thinking about that is something like, hey guys, give me like a card that would have, like one card that you would pull out that would have 2 different things true about it. Tell me something, one card that has 2 different things true about it. A red what?
Oh.
Oh, a 3 of diamonds? Cool. So we could say, in our standard deck of cards, we could say we're talking about 3s, and then we could talk about diamonds. Right? So if we're trying to talk about a card that is a 3 and is a diamond, then we could say, okay, how many 3s are there in a standard deck?
4.
Yeah, there's 2 different black 3s, and then there's 2 different red 3s, and one of those red 3s is a diamond, right? And then diamonds would also have like an ace and a 2 and a 4 and a 5 and a 6 and a 7 and an 8 and a 9 and a jack and a queen and a king. Anyway, but we could talk about this in terms of the overlap in a Venn diagram. You guys know Venn diagrams, yeah? Then, I'll just write that. So the last thing for today is P of A and B, which is also known as an intersection, snazzy vocab word. Intersection, think the Venn diagram intersecting is equal to the probability of A times the probability of B, such that A, and this gets to be a little bit funny because this is just a vertical bar. That means such that. We'll talk about that more next time. Bye, guys.
Oh my god.
Yes, it would.
I'll buy them.
Later, Gators.
Versus